Hello, everyone, and welcome back. I'm really glad to have you here in our second session of learning ANSYS SpaceClaim. In the previous session, we talked briefly about the background and philosophy of SpaceClaim. From this session onward, we'll start moving into the practical, hands-on part of our training. In this lesson, we're going to cover two important topics: a general introduction to the working environment, including the main 3D design area, the ribbon toolbars, and how the interface is arranged. A detailed look at the structure panel, where we'll break down its main sections such as the structure tree, layers, groups, and views. By the end of this session, you'll have a clear understanding of the overall interface, and you'll know how the structure panel helps you organize, manage, and control every part of your model. When we open the software, the working environment is divided into four main areas. Each of them has an important role in modeling and design. Ribbon, top toolbar, located at the top of the screen, very similar to Microsoft Office. It contains several tabs, such as Design, Display, Measure, Prepare, and more. Each tab groups a set of related tools. For example, the Design tab is where you find sketch and modeling tools, while Display tab controls how your model is shown. Structure tree, left panel, found on the left side of the screen. It's basically a hierarchical list of everything in your model: bodies, sketches, surfaces, groups, and assemblies. You can use it to select, organize, hide, or show components easily. Think of it as the navigator of your project. Design area. This is the big central workspace where you actually create and edit geometry. All of your sketches, surfaces, and 3D solids appear here. You can rotate, zoom, or pan the view to see your model from any angle. Status bar. Located at the bottom of the screen, it gives useful information such as measurement units, grid and snap status, cursor position, and other quick settings. It's a small but very helpful bar to check what is active during modeling. In summary, the SpaceClaim workspace is organized into ribbon at the top, where you access all tools and commands; structure tree on the left to manage and navigate your model's components; design area in the center, the main 2D 3D workspace where you actually build and modify your geometry; status bar at the bottom to monitor units, snap grid settings, and see quick feedback while modeling. Before we explore the Views panel, it's essential to understand how to navigate the geometry with the mouse, because this is the quickest way to control our viewpoint. With the scroll wheel on the middle of the mouse, if we press and hold the scroll wheel and then move the mouse, the geometry will rotate freely in any direction. This allows us to examine the model from any angle without limitation. It's the main method of rotation in 3D space. Now, if while holding the scroll wheel, we also hold the control key on the keyboard, instead of rotating freely, the model will only move linearly in straight directions. This is called panning. The geometry shifts left, right, up, or down while keeping the same orientation. And of course, simply rolling the scroll wheel zooms in and out smoothly. By combining these three motions, rotate with scroll wheel, pan with scroll plus control, zoom with scroll movement, you get complete control of the viewpoint in 3D. Now let's move to the Views section in the Structure panel. Here, you will see a list of standard orientations such as isometric, trimetric, top, bottom, left, right, front, and back. Each of these has shortcut keys on the keyboard for quick access. For example, Control 1 for trimetric, Control 2 for top, and so on. But the easiest method is to remember that a simple double click on any of these options will immediately change the view. For example, double-clicking on top instantly rotates the geometry to top view, and double-clicking on isometric brings it back to standard 3D orientation. In addition to defaults, you can also create your own custom views. Let's say you've rotated and zoomed into a part of the model in a way that's useful to your work. You can simply go to the Views panel, press Create, and give this orientation a meaningful name, for example, Detail Area or Custom Angle. From that moment on, your new view will appear in the list, and just like the default ones, it can be recalled instantly by double-clicking on it. In SpaceClaim, one of the most important areas that we often use is the structure panel, and inside it, the structure and layers section. This section works like a tree view of our model. Every piece of geometry that we create, such as solid bodies, surfaces, sketches, planes, axes, or points, appears here in a clear hierarchical order. You can think of it as the table of contents of your design, where you can quickly find and manage everything that exists in the model. By default, all objects are placed inside one main category called the default layer. However, for better organization, we can create new layers. Layers are very powerful because they allow us to group our geometry into specific categories. For example, one layer for bolts, another one for the housing, and another one for construction geometry. This way, instead of dealing with all parts at once, you can simply control entire groups through their layers. Each layer has several controls that make your work much easier. You can turn the visibility of a layer on or off. So if you do not want to see certain objects on the screen, you can simply hide their entire layer with one click. You can also assign different colors to each layer, which helps a lot in distinguishing different parts of an assembly, especially when the geometry becomes complex. But here it is important to note something. In order to apply a different color or any other property to parts through the layers section, the shapes need to be separated into distinct bodies first. We have already done this preparation step in advance, so that right now we can directly show you the effect of using layers. Later in the course, you will learn exactly which tool is used for separating bodies and how that process works. But for now, our purpose is only to demonstrate the application of layers so that you clearly understand their role. That is why the structure and layers section is not just a simple list of objects. It is actually the backbone of how you manage and navigate your entire model. As you move forward and create more parts, assemblies, or reference elements, the tree inside this section will grow. And having a clear strategy with layers will save you both time and effort. For example, imagine you are designing a machine that has many fasteners, bearings, and structural components. If everything is left inside the default layer, the tree quickly becomes cluttered and confusing. But if you separate it into meaningful layers, you can instantly hide the bolts to focus on the housing, or you can show only the construction geometry without being distracted by the main components. With this approach, layers become a very practical tool not only for visual clarity, but also for efficiency during the whole design process. So remember, at this stage, our goal is simply to let you experience the way layers affect your model in terms of organization, visibility, and color. As we continue, you will gradually learn the detailed tools that prepare the geometry for proper use with layers, including the commands that separate bodies and give you full control over how each element is displayed. For now, just keep in mind that the structure/layers section is the foundation of model management in SpaceClaim, and understanding it early will make future steps much easier. In the structure panel, just below the layers section, we can find another very important part called selection. This section controls how we select objects inside our design window, and it becomes extremely useful when the geometry starts to get more complicated. Normally, when we click in the graphics window, SpaceClaim tries to understand what we want to select, whether it is a face, an edge, or a solid body. However, sometimes our models are crowded, and it is not very clear what exactly will be picked. That is where the selection section helps us take control. For example, here I selected a single edge of the model. Immediately, in the selection panel, several options appeared. These options allow me to extend the selection to similar edges, such as edges with the same length, edges with the same length and orientation, or edges with the same length inside the same face. This means that instead of picking each edge one by one, I can instantly select all edges that share these properties. It makes the process of working with repeated geometry elements much faster and more accurate. Now let's look at another example. Here I selected a face of the model, specifically the circular cross-section on the cylinder. Again, the selection panel reacted and gave me different options. In this case, I can select coincident faces, faces with the same size, faces with the same area, or even faces with the same color. These tools are very helpful when you want to apply an operation, such as pulling or moving, to multiple faces that share similar characteristics without needing to select them manually, one by one. So the key point to remember here is that the selection section adapts dynamically depending on what type of entity you choose: edge, face, or body. Each time, it suggests logical ways to expand or modify your selection to similar objects. In the Groups section of your workspace, you create durable, human-readable labels for geometry, so downstream steps can refer to those labels instead of reselecting faces, edges, bodies, or volumes each time. To name something, you first go to the Groups panel, then visually pick the face or the volume you want to capture. And after the selection is made, you press the Create NS button to create the named selection and type its name. The workflow is therefore very direct. Open Groups, click the geometry you want to include, click Create NS, and immediately enter a descriptive name. That single act of naming turns a transient selection into a stable handle that the mesh, solver, boundary condition dialogues, and post-processing tools can all use. When selecting a volumetric part quickly, use the familiar Click, Expand, Click trick. Click once on a face to pick that face, click a second time to expand the selection to the contiguous patch or component, and click a third time to capture the entire body or volume. After that, triple-click, you can hit Create NS and give the selection a name like Inlet Vol or Heater Block Vol. If your application has explicit selection modes, select faces, select bodies, select volumes, you can switch to the appropriate mode before picking and then press Create NS directly. But the 3-click visual method is handy when you're working by sight. In short, open Groups, select the geometry, use triple-click or body volume selection mode, press Create NS, type a clear name, and rely on that name as the stable reference for meshing, boundary conditions, and post-processing. Doing this consistently saves time and prevents errors later in the workflow. I hope this video was useful for you. To benefit from Mr. CFD's services, including simulation, consultation, and training, visit our website and contact us via these addresses.